Welcome students to the first video in trigonometry, and of course we start with angle, and angle is surely uh, quite a simple concept, uh, and let's look at what exactly an angle means. Now, how do you create an angle? An angle is mathematically created by the rotation of a particular ray. Now, suppose so. This is a ray, and starts from a particular point, and we usually denote that point as O. That's the point of origin. That's from where the ray is starting, and it goes in a particular direction. Let us call this ray OA. Now, after rotation, with the same origin, the ray stops at a new location, and this new point is B, and so you get that's the final position of this particular ray after rotation, and final position is denoted by OB. So note the point that OA and OB doesn't represent two rays; it's the same ray, and it's OB is the ray after it has rotated through a particular and that rotation, that measurement of the rotation, how much it has rotated, that is what is called. So here this particular arrow here actually denotes the angle. So angle is a measurement of the amount of rotation which has taken place when this ray has rotated from an initial side and has now ended at a terminal side. So that's the meaning of it. So angle is refers to the amount of rotation. So that's the meaning of it. Now the point which is denoted by O, that's the point of origin of the particular ray, and that's the point also through which the ray is rotating. That particular point is what is called the vertex. Now one important point, and of course a simple point, is that suppose so in the we are continuing with the previous case. It's OA, it's OB, and so we are dealing with the angle AOB. Now suppose the distance here is x meters, and because the same, we are dealing with the rotation of the same ray, that simply means that OB is also x meters. And suppose I am increasing it to 2x, that means now we are getting a new ray, that is I'd call it OA1, and that's the final position of that particular new ray, that is OB1, and this is 2x, and this is also 2x. Now the key point is that if this angle is theta 1 and this the new angle is theta 2, then the key point is that theta 1 is equal to theta 2 because the amount of rotation rotation is same. That's the key point. But also note that the area of that particular angle, that's the area covered by the rotation, is not same. So if you're taking the area of if you're taking the area of theta 1, that is not equal to the area of the area of that particular sector. So it's the angle measurement which is equal, but the area which is denoted by that particular angle, that is not same, because we know that the distance of the ray has been altered. So that's a simple but a key point. Now in the cases which we have discussed till now, the ray is rotating in the anti-clockwise. That's the direction opposite of what we see when the hour and of course the second hand of a typical clock rotates. Uh, so you have the once again the ray OA, which is stopping the rotation at OB. This here the rotation has been in the anti-clockwise direction, and there's a particular meaning to it because it simply means that this is a, if I call it the angle theta 1, then theta 1 is a positive angle. So it simply means that when we are measuring angles in the anti-clockwise direction, those angles are denoted as positive angles, and which simply means that if it's in the opposite direction, that is if we of course kindly note that the distance is the same, of course, and this is OA, OB, and to make it different, let us this A1 or B1. So here you have a second angle coming up. The only difference is that here the rotation has been in the clockwise direction. So if the rotation is in the clockwise direction, we'll be dealing with a negative angle. So theta 2 here is a negative angle. Now, when we are discussing angles like this, an important point to know is that so that's the angle. This is angle AOB. Now the point to note is that I am drawing it on a two-dimensional plane. So which simply means that this all these angles are measured or can be drawn on a Cartesian coordinate plane. Now, in the sense that suppose this particular angle, I mean, suppose the ray OA continues rotation and it stops the rotation at a particular position where the new position that is this OB of the ray is perpendicular to the original position. That is OB. That's the terminal side is perpendicular to the initial side, which simply means that we are dealing with an angle of 90 degrees. Of course, in the coming videos, we'll be looking at how to measure angles. And of course, we are dealing with a right angle, and you can see that this also corresponds, and we can draw it on a graph, and this corresponds to a. And if we continue with the same process, and if the ray rotates and comes back to the same position, we can see that it can cover the coordinate axis. So this would be the y-axis, and this would be the x-axis, and so which simply means that in such a rotation, the array would be dividing the entire two-dimensional plane into four equal sectors. That is sector 1, sector 2, sector 3, and sector 4. And we call these sectors quadrants. That is first quadrant, second quadrant, third, and the fourth quadrants. And of course, the angles associated with each quadrant is also same. And because the first quadrant is 90 degrees, it simply means that when we cover the entire area and comes back to the initial position, so that means the final angle would be 360 degrees. So that's the point, and we can superimpose this rotating ray on a two-dimensional plane, and also include the x and y axis. And even though this point, this concepts are simple, it has a lot of importance when we go into the deeper portions of trigonometry and also in solving specific problems. And to wind up this particular video, the interesting point is that as this ray, suppose this ray is this is its length is x meters, and so it simply means that as the ray rotates and comes back to the initial point, we are dealing with a circle. And that's also even though trigonometry is basically defined as the study or the measurement of uh, the sides and angles of a triangle, we can see that why the subject gives equal importance to circles also. Thank you.